Okay, Lily, time to talk about the Sirius Red Protocol. Hopefully, I can draw some pictures and make it make more sense visually. Otherwise, at least you'll have this as a very clear-cut guide on what exactly you're doing. There are major steps involved here, but I wrote more steps later on. The major steps here is first we're going to stain whatever samples you've gotten from your experiment or the standards that you've created in Sirius Red working solution. We do have to make this working solution, but it's very easy and it lasts for a pretty long time. You then wash that sample in the same tube to remove any unbound dye with the acetic acid. So we're putting acetic acid into the tube with the collagen and Sirius Red already on it so that we can kind of get some of the unbound Sirius Red away from the collagen so it doesn't try to bound over and over again. Then we elute it, which is just a fancy way of saying diluting a solid or washing a solid. Eluting that bound dye with sodium hydroxide, NaOH. Don't worry, teach you how to make that as well. Very easy and lasts forever. And then we will read that eluted dye, the supernatant of this last part right here, at approximately 540 nanometers in a spectrophotometer. So how do we make the Sirius Red stuff? All we gotta do is take this Sirius Red, or what I think I bought you was called Direct Red 80. It's the same thing. We're gonna take 0.05 grams of it and put it into a container of 50 milliliters of 0.5 molar acetic acid. This is what you made today. I'm recording this on Thursday the 11th, and you made that today with me. So we will be able to use the stuff that you've already done with me. You want to mix it until it's fully dissolved, no foam, no powder, no nothing. And once we have full dissolved, you'll store it dark. I would wrap it in foil if I were you and label the outside of the foil as well. You can store it at room temperature of 1 to 2 months in your little tub, or if you're worried about it for being okay into March, then store it in the fridge for up to 6 months. Totally fine. We will also use this same 0.5 acetic acid solution as a wash, not the Sirius Red dye, but the acetic acid that we mix the dye with. The elution solution, say that 5 times fast, is 0.1 molar NaOH. It's very easy to make. I probably already have some at that concentration in my corrosives closet. If not, I'll definitely have some at a different concentration, either at 1 molar or 10 molar. So you get to do the M1V1 equals M2V2 to make 100 milliliters of that stuff. Sounds pretty easy to me. Note that you're going to make it the same way that you made the acetic acid because NaOH, sodium hydroxide, is a strong base. So always put the water in the flask or beaker first, then slowly add the concentrated NaOH, just like we did with the concentrated acetic acid. So, step one, once you've made all of those solutions, is to grab a chunk or a disc of that collagen. We can make ourselves like a cutout thing if we're going to use the thing that you're using for the dish, or if it's going to be in the tube, just keep it in the tube, totally fine. But each collagen disc should already be labeled in a microtube so you can keep them straight. And I would have many of these microtubes out at the same time because you're just going to go pipetting over and over. In this case, we're pipetting 1 milliliter of Sirius Red into each microtube, so they're almost going to be full of both collagen and Sirius Red. And you want to ensure that the sample is completely submerged, so you might have to pick it up and shake it up a little bit to make sure it gets on all sides of the collagen. Once you've stained, incubate it for 30 minutes at room temperature. You can put this in the incubator at room temperature if you're worried about people bothering it or bothering you. But the easier way is actually just to put it on a rocker or a 3D shaker for 30 minutes because you'll want to go around every 5 minutes and flick it or gently rotate it to make sure the Sirius Red is mixing with the tube all around the collagen solution. But if you put it on the rocker, then the rocker will just go back and forth, and your tube will go back and forth with it and literally allow the mixing to take place inside the tube. You could even put these into 15 mil tubes instead if you want to make sure that they get all the way rocked back and forth. Totally up to you. This rocker and 3D shaker will do the jostling for you, and it's a whole lot more fun to watch do that. You guys get excited when you see my rocker, so feel free to use that if you like. Step 3, we're going to pellet the sample, which means we're going to centrifuge it by putting all these tubes in a centrifuge and spinning it down at 2,000 to 5,000 RPM for about 5 minutes or so. You don't have to watch it for 5 minutes. You know that once you put it in there and you shut the door and you turn it on, it should just spin, spin, spin for 5 minutes, and it has a timer on it. What's going to happen is the dyed collagen will submerge and sink down to the bottom because it's more dense, and it will be the pellet of your tube, while the supernatant will be this red gooey stuff that is unbound red dye. And the amount of unbound red dye will be based on how much collagen is left that hasn't been degraded by your MMP, or collagenase, we should say. Once you've spun it down, you'll want to take a pipette and suck out the supernatant, the dye that's unbound, or you can pour it out into a waste beaker. You just can't disturb the sample. Don't pour the pellet out with it. That's why I would recommend taking a pipette and sucking it out. Even maybe a micro pipette and sucking it out, because I know you guys have more dexterity with the micro pipette. Then you have to wash it because we have a pellet now that has a bunch of collagen in it, but it might have some leftover Sirius Red that isn't actually bound to it. It's kind of like a rinsing off the soap off the dishes in the sink. We're going to add 1 milliliter of the 0.5 molar, I forgot to write molar right there, acetic acid. Make sure you close it before you flick gently or vortex because this is an acid and you don't want that splashing all over the place. Centrifuge it again at the 2,000 to 5,000 RPMs and pipe out the supernatant again. At this point, you will be basically rinsing the collagen with the acetic acid, and now we're getting rid of that. The elution is pretty much the last step before your data collection with the spectro, but this is a special step because you might be running out of time in the class period based on how long this is taking already. We've already incubated for 30 minutes. We've done a centrifuge for 5 minutes. You got plenty of samples, so it's going to take you longer to pipette stuff. So at this point, you have to make sure you have enough time in class to do the following things. You add 1 milliliter of 1 molar. Try that again, Mr. S. That's 1 milliliter of 0.1 molar NaOH, and flick it and briefly vortex. This sounds like a lot of liquid, but remember you're pouring out the liquid each time. So at this point, really we have the collagen sample and 1 milliliter of liquid, and that's it. You're going to incubate it at room temperature 5 to 10 minutes. Then you centrifuge it one last time at 2,000 to 5,000 RPMs. But this time, instead of the pellet being saved, we're going to save the supernatant. This elution is grabbing all of the solid collagen and all of the leftover Sirius Red that's applied to it and kind of putting it into solution again, dissolving it, eluting it. And so now we care about the supernatant, the stuff that is in the liquid. You'll want to transfer that either to a cuvette if you're ready to take measurements right away, or an entirely new tube if you're not ready to take measurements. Might I suggest a 15 mil tube or a micro tube? You'll want to dilute it with 2 milliliters of distilled water. That's why I actually suggest a plastic 15 mil tube, because a microtube does not hold 1 milliliter and 2 milliliters of distilled water. However, this 2 milliliters is flexible. The only thing you have to definitely do is have the same amount of liquid that you're adding at this point for every tube that you do from here on out. Why? Because you want to dilute it at the same concentration that you do in every single sample. Otherwise, your concentrations in your cuvette will not be reflected to be the same. So if you start doing samples and add the 2 milliliters of liquid, and then you say, oh, this one looks like it has a little bit less liquid in it, maybe I add 2.5 this time. you have now diluted your sample more and gotten wrong data because of it. So pick a number, 2 or 2.5, and stick with it. And I would assume 2 or 2.5 would be a good number because remember, you want 3.5 milliliters of liquid in the cuvette in order to be able to have the light pass through it appropriately. Now, if you've run out of time, we're going to store it in that new tube with that diluted amount of water and place it in the fridge for 24 hours. And I would actually make yourself like a little foil pack that wraps around all the tubes at the same time so no one touches it. And then you can bring the samples back to room temperature. I can literally pull them out in the morning. They'll be ready for your third hour. So you can gently mix them before the spectro and they'll be at room temperature ready to go. You don't want them cold because they might give off some, what's the word I'm looking for? The condensation on the outside or inside of the tube based on the changes in temperatures in the ambient water and ambient vapors in there. So you don't want the condensation to affect your cuvettes later on because your concentration was off from the condensation that occurred. So let's bring it to room temperature slowly. The spectro has a couple different steps. First, you have to blank it, which doesn't mean like literally just turn out and reset it all of a sudden, but it's to actually put in a blank cuvette that is filled with a blank solution that would be like zero of something. In this case, because we're using NaOH as an elution buffer, and because we're diluting it with distilled water, we're going to fill a cuvette with just NaOH and distilled water, which will match what the spectrophotometer would say is nothing because there's no collagen in it. There's no Sirius Red in it. Then, once we blank it, and I'll show you how to use the software the way it is, you insert the sample with the clearest side facing the left where there's an arrow on the spectrophotometer. The ridges in the cuvette should be facing you and facing the back of the spectrophotometer so that the light can go through the clearest side only. We'll hit collect, we'll wait a minute or so, a bunch of spikes will appear on the screen. We're going to look for spikes specifically at the 540 to 545 nanometer mark, and we will record what is called absorbance. Absorbance is the amount of light in a relative amount compared to, like, say, a bunch of light versus a little bit of light. It'll be like a decimal number or something like that. We'll record that number and and put it in a graph later along with your standards so we can figure out the concentrations later on. That's it. It's not so bad. It really isn't. All we're doing is we're running the spectro just like you probably anticipated. It's just that the Sirius Red is a dye, an indicator of how much collagen is in there, and therefore will be kind of adding the dye and taking it out, kind of like making a tie-dye shirt. We add the dye and then we wash out the dye and some dye is left over. It's the same idea. Cool. Let me know how I can help.